Hi, this is probably the most important topic in all of chapter 14, and I don't know why they chose to do it last. I like it the most. It's also one of the easiest, and it will be for you too. It's called symmetry. Basically, it starts with this. We're looking at 4 different country flags here, and they want to know which flags can be folded about some line so that the halves would coincide. So for Canada's flag, if you folded it right down the middle, then they would meet up on both sides. Switzerland's flag, you could fold it right down the middle and they would meet up, but you could also fold it horizontally and they would meet up. And you could also fold it diagonally and they would meet up. Either diagonal and they would meet up. For Japan's, you could fold them horizontally. Why couldn't I fold it diagonally though? My circle would meet up, but if I were to fold it diagonally, my sides would not meet up. What about for Israel's? I could fold it both ways, but I can't fold it diagonally either because my sides would not meet up. It's because Switzerland's is a perfect square that you can do that. If you look down here, they talk about something rather interesting. I'd never seen this before, but they talk about it being symmetric. That's what this stuff was up here. But you can also have symmetric images about a point, not just about a line. So this image is symmetric about this line. You can fold it in half and it would meet up. But this one is not symmetric about a line. If I folded it across the line, it wouldn't meet up. But it is symmetric about the point 0. Because if I took it and I rotated this bottom fish around that point, I would get the top fish. So that one's symmetric about a point. C has tons of lines of symmetry, which is what we call these lines, lines of symmetry. It has one here. In fact, it has one on each of these. It's symmetric about each of these different lines. And it's symmetric about this point, because if we rotate it, we're still going to get the same image. Here we have one line of symmetry. Just that one straight down the middle, just like here, just that one straight down the middle. If we were to rotate this, it's not going to help us any. We have to rotate a whole 360 degrees to get back to that crab. Okay, so you understand symmetry about a point and symmetry about a line. So if it is symmetric about a line, that's called reflectional symmetry. And that line that it reflects on is called the line of symmetry. If it is symmetric about a point, that's called rotational symmetry. And that point is the point of symmetry. So when you look down here, you can find out whether or not it is reflected about a line of symmetry, or if it's rotational about a point of symmetry. So for this one, it's rotational about a point at the center. I take that back. It's not. This is, that rotates, but only that because this center thing will not. It'll be upside down. That's kind of interesting. Line of symmetry here, line of symmetry there, nowhere else. Line of symmetry here, nowhere else. Okay. Instead of worrying about this, I wanted to look at a couple of problems. over here. Just the letters. I want to look at the letter, I'll look at letter B, K, and T. So for B, it does not have a line of vertical symmetry because I can't draw a line through it and it be symmetric vertically. But it does have a line of horizontal symmetry. For K, the way they have K drawn, because that's what you have to go by, it does not have vertical symmetry and it does not have horizontal symmetry. And then for T, the way they have it drawn, it does have vertical symmetry because you can draw a line straight down the middle and it would be symmetric. It does not have horizontal symmetry. You're going to have to figure out for each of these whether it has horizontal symmetry, vertical symmetry, or neither. And then you should be able to do problems 10, 11, and 12. And that's all I'm interested in. So that's your homework for tonight, problems 10, 11, and 12. Okay. That ends this particular section, which means you'll have a review and then you'll have a test. Here's the thing. Your test is going to be a construction, which means there's really no point to a review because you're supposed to know how to do those constructions. So there is no review attached. I told you all this stuff was in blue. So yes, you do need to do your homework tonight. I'll be looking for it when I grade your notebook. But I gotta be honest with you. It's the constructions that matter. And I know we only did one day going over constructions, but I'm going to tell you a construction. I'll have it typed up. It'll be in the thing. I'll send it to you exactly what you should do. And if you follow the directions, then you should be fine. But you'll have to know all the constructions in order to do it. Because that's what I'm testing, whether or not you know those constructions. So, this is what I'm suggesting for you. Take some time and go through and review how to do some of those basic constructions that my mom did with you. And then you can do the construction that's your test. This is how your test is going to be done. You're going to read it, and I'm going to tell your mom to give you 2 hours to get it drawn. 2 hours, and that's it. So after 2 hours, she goes in there, she takes pictures, she sends it to me. So you're going to have to work a little bit quickly. You can't sit there and worry over, what am I doing? You got to know what you're doing. So it's all about being able to construct what I ask you to construct. I hope you will be successful, and I hope you will listen to the directions. But since I'm going to use words like symmetry and reflection, etc., in it, make sure you finish this stuff. Okay, bye.